Hello, Mr. Fry's Algebra 1B, taking a look at the Unit 6 Homework 2, Powers of Monomials and Geometric Applications. This is not due until tomorrow, the 19th of March. I'm going to do the odd ones and kind of give you some guidance so that you could do the even ones. So try the even ones on your own, and you should be good. Don't worry about making mistakes. I have this when we're multiplying, when we're raising a power to a power. Okay, so the power of 4 is raised to a power of 2. We multiply those exponents and to create our new exponent. So here we have just 4 times 2, which would be 8. So x is just raised to the 8th power. This one is just going to be k when whatever 9 times 5 is. So you can put that there. For number 3, you're just multiplying the 3 and the 2 and multiplying the 3 and the 7. For number 5, don't mind that for a second. I just want to show you something. The 4 is going to go for the 3 because it's in parentheses. So 3 to the 4th power is 81. And then we have y here, and y is to the 3rd power is 4 times 3 is 12. Say that 3 was out of the parentheses. Well, then you wouldn't raise it to the 4th power because it's not included in the parentheses. So this would just stay 3, and the 4 times 3 would be 12. So this would be 3y12 if it looked like this. I just wanted to point that out. Big difference if the number's in the parentheses or out of the parentheses. So this one's in the parentheses, so negative 4 squared is going to be 16, and then it's going to be x to the 4th, because 2 times 2 is 4. Number 7, negative 5 cubed is negative 125. Y to the 3rd power, 3 times 3 is 9. Go ahead and try 8. Number 9, plug in that half, and then x to the 4th. This 7 times 4 is going to go with the x, and you can just put that right on top. And then 2 to the 7th power is 128. Go ahead and try number 10. Number 11, sorry this one looks so ugly, but I started to write my 8 here, and I don't know what I was writing there. But anyways, so we have half on the outside, that just stays on the outside, kind of like what we did up here in this example. But 4 to the 2nd, 4 squared is 16, and then k to the 5th to the 2nd power is 5 times 2 is 10. Okay, and then we just take half of the 16, so half of the 16 is 8, and then the k to the 10th stays. Number 13. We're just taking the 7 times the 5, and then the 7 times the 3. And then we're going to multiply that all by this m squared n. Now this goes to what we were doing yesterday. Remember when we were multiplying the product rule? Then we add. When we're just multiplying exponents, then we are adding them. Okay, we notice we're not raising them another exponent like what we've been doing earlier today. We are just multiplying exponents, and then so when you multiply these monomials, is what I should be saying, you are you're going to just add the exponents. So I'm going to add these exponents. So m35 plus 2 is m to the 37, and n21, and this n, since I'm multiplying only, 21 plus 1 is 22. So n goes to the 22nd power. Okay, this one, we've got a couple things going on here. First of all, I just did what's in these parentheses to the 3rd power. So 2 becomes 8, 9, 3 times 3 is 9, or x becomes 9. With this y, 2 times 3 is 6. This z, 2 times 3 is 6. Okay, then I did what's in these parentheses. X becomes 8 because 4 times 2 is 8, and the z is 1, so 4 times 1 is 4. When you don't see any exponent there, You just assume that would be to the first power because that would be the same as z itself. Now I'm multiplying like I did yesterday, like this example problem, and all you did was add. Remember yesterday, the product rule, I added the 3 and the 8 to get 11, I added the 5 and the 10 to get 15. You're going to do the same thing with this part of the problem now. Okay, so the 9 and the 8 added is 17, the 6, and there's no y over here, so it just stays y equals y to the 6th. And then z to the 6th and z to the 4th. 6 plus 4 is 10. And then 8, just multiply, there's nothing else, so I just bring that 8 down. Number 17. This 3 goes with the negative 4, and so negative 4 to the third power is negative 64. And you bring that 3 in, and n, you bring that 3 in to cube that. Make it to the third power. Third power, you could also say cubed. Kind of like to the second power, you could also say squared. And then this part of the problem here, let's do this part of the problem. Negative 2 to the third power is negative 8. M to the second power, and then you have it to the third power. You multiply those powers to get 6. Now I'm multiplying, so I'm going to multiply negative 64 and negative 8, and that gives me 512. M to the third power plus m to the sixth power gives me 9. N to the third power, I just bring it on down because there's nothing else to add to it. So there's 17. 19, I squared everything that's in here, and I ended up with this. This I just brought down because I couldn't, there was nothing to do with that. Until now I'm multiplying these. So negative 324 times negative 1/6 is just negative 324 divided by negative 6 gives me 54. M to the fourth and an m to the first here is 5. M to the fifth, n to the second, and an n to the second. 2 plus 2 gives me the 4, so n to the fourth. For 21, I took to the third power everything in parentheses, and you have that here. And I have my plus, and I just kept this the same. Now remember, when we're adding, this is like when we were adding and subtracting here, you can only add like terms. Like I added this and this because they're like terms, this and this because they're like terms. You can only add like terms. These happen to be like terms because I have x to the 15, y to the 21st, x to the 15, y to the 21st. So I can add these two big numbers. Negative 8 plus 7 is just a negative 1. If you wrote a 1 there, that's fine. It's just negative. And then you just bring down the like terms, the x15, y21. 22. We're finding the perimeter, so we're going to add these. Sorry, that 4 is ugly. And I'm going to add these. So add these to both of these. So here's that top, here's the bottom, the right side, the left side. I can only combine like terms. So I get 10a squared b to the fourth, that's a b, plus 6ab to the second. That's supposed to be a little 4 up there. I can only combine the like terms when you're adding monomials. 24. And you could use the same formula for number 23. Perimeter and area. I just found the perimeter of that one. So I'll go back and at least you got the perimeter. The area for this one is half base times height. And so the half the base times the height, you are just going to multiply all that together, and you end up with 16 m to the third times n. Okay, and then for number 26, finding the area, just the area of a circle is pi r squared, pi times r to the second power. So I just took that r value. Here's your pi. Here's the r, which is the radius. The radius is from the center to the outside. That's 3x cubed times y, and I square it. Now when I'm squaring it, I square the 3, it becomes 9. I take 2 times 3, that gives me 6. 2 times 1 is 2. Now I'm multiplying this times 9, and I get 28.26. And I still have my x to the 6th and y to the 2nd. And that is the area for that one. Okay, hopefully this is helpful. And don't forget to also, try to get the area for this 22. And this one is the area. And try to get the equilateral. So this one, real quick, let me go over this then for the perimeter. This is the area. So the perimeter would just be 8mn plus 8mn plus 8mn because it's equilateral. So 8 times 3, so you have 24mn. Okay, so this one would be the perimeter, this one would be the area. This, you would multiply these together. This is the perimeter, that's the P. This is the P, perimeter, this is the area. Okay, so the area is just going to be the base times the height, or the length times the width, I should say. So 5a2b4 times 3ab2. So this is like these, okay, from yesterday. So I'm going to do the 5 times the 3, so that gives me the 15, and then you just add your exponents. So a 2 plus 1 is 3, and then b 4 plus 2 is going to be 6. So this is going to be my area. All right. Okay, hopefully that is helpful to you, and good luck on the rest.